I'm going to start off by actually going over some of the material from the last quiz that we took, and it's at the very bottom of the worksheet that I gave you today, Day 13 Mixed Log Practice. So you can see that it kind of shifts gears back to like what we were doing before. So I'm going to do a couple of these with you, and then remember I'm going to also send you the keys so you can check those tonight. Okay, so the first thing you would do for number 26, you have to raise this power of 3. So 2 cubed is 8, x squared cubed is x to the 6th, y to the 5th to the 3rd is y to the 15th. So I'm just multiplying. And I'm going to do the same thing for the other monomial here. So negative 1 is really what's out front here. So negative 1 to the 5th is just a negative 1 again. X to the 4th to the 5th is x to the 20th. Y to the 3rd to the 5th is y to the 15th. And now I have to multiply everything together. So my coefficients get multiplied, and that gives me a negative 8. X to the 6th and x to the 20th, I add those and get x to the 26th. Y to the 15th and y to the 15th is going to give me y to the 30th. And that will be the answer for that one. And then for number 28, let's do that one. I'm going to remember that I can rewrite these as rational exponents. So that'd be like 32, and it'd be to the 1/4, m to the 7/4, and then n to the 2/4. And then I'll simplify where I can. Now, you're going to use your table and kind of look and see, is there some base that when you raise it to the 4th power that you get 32? And there is not. But one of the factors of 32, which is 16, is on that list of powers. So 2 to the 4th gives me 16, so I know this will simplify. But that's going to have to still be multiplied by 2 to the 1/4. So the way this will simplify is 16 to the 1/4 is just saying the 4th root of 16, which is 2. Then underneath the radical with a root of 4 is going to remain this 2 right here. M to the 7/4, you see that 4 will go into 7 one time. So the m to the 1st will go here. But then I'll have 3 left over, 3 remaining. And then n squared, I could simplify that down to 1/2, but then it wouldn't fit under this same radical. So what I'm going to do is just leave that one as it was originally. So this would be your answer for that one. And then finally for ones like 29, I would just rewrite this with a root of 3. So I'm going to find the cubed root of 64 and then raise that to the negative 2. And then the cube root of 64 is 4. So 4 to the negative 2 is going to be 1/4 squared, which is 1/16. So that is how you do a few of those problems from that worksheet. Now moving on to the extra credit opportunity I gave you today, I'm going to do, I'm going to kind of go through some of them and do as many as I can, and then I'm going to pause it and let you finish the worksheet, and then I'll come back and let you check your answers. Okay, so just starting with number 1, 64 to the 1/3 is 4. So remember, you kind of loop around. 9 to the 1/2 is 3. That's true, obviously. So this is rewriting the log back in exponential form. So going the other way, we go from exponential to log. And remember, I told you the first thing you do is write the word log. Your base is a 3, and you still can kind of loop around like that. So log base 3 of 1/81 is equal to a negative 4. And that's definitely true. So write log. My base is a 3 of 243 is equal to 5. So that's how you do those. Now evaluating, we have to use some of our properties that we've talked about. The property right here basically says that I can bring the power down front. So it's 3 times log base 5 of 5. Well, we know this log base 5 of 5 to be 1. So this is just going to give me a 3. And we also learned in class, I think this was yesterday, that if you have a log with a base and then that same base to some power, let's just call it n, the whole thing will simplify down to that n, and that's what happened here, simplify down to 3. Okay, simplifying number 11, 1/3, and then I'm going to go ahead and evaluate log base 3 of 27. It is just the number 3. So this is just going to be 1/3 of 3, which is 1. Quickly, base of 10 here, and I have 6 zeros, so it's going to simplify to 6 because 10 to the 6 would give me this answer. 10 to some power, so you can kind of think about rewriting it. 10 to some power is 1/1000. Well, you know you need an exponent of 3, but it has to be negative because it puts it in the denominator, so x is a -3. Okay, let's do 17. And this is the one that some of y'all were struggling with in class because 8, it doesn't have a power that you can actually use right offhand that gives you 16, but you can change this to a common base of 2. So 2 cubed to the x, and that's still 8 to the x, and then I'll use 2 to the 4th here. So remember I set 3x equal to 4, I divide both sides by 3, and x would be 4/3 for number 17. So that is how you'll do those. And for number 19, this would have to be on your table because we would not expect you to know that. But 6 to some power is going to give us 1296. So that is going to be to the 4th power. So 6 to some power gives us 1296. So rewrite it, and then you're just going to literally use your table and find that x is going to be a 4. All right, so moving on. Now we're going to start the expanding and the condensing, which is really important. So to expand fully, remember that we're going to follow our order of operations, divide, then multiply, and then deal with our power. So I'll start with number 21. So I have division going on here. So it's going to be log base 2 of x minus log base 2 of y squared. The only thing I have to do now to finish it is to bring the 2 down front. So I'm going to just write it right here, and that is your final answer. 23, I have a couple things going on. I have multiplication, but both the a and the b are being raised to the power of 2. So that's important to notice. So I actually need to do something. I actually need to recognize that I can't break this apart until I bring the 2 out front. So I'm going to bring the 2, but it's multiplied by log base 3 of a plus log base 3 of b. So that's how you would do one like that. All right, so those are the expanding. Now let's condense, writing as a single log. And just kind of think through for the expansion, 21 through 25, if you have division like x divided by y squared, I know I need 2 logs. So I have a log and then another log. The power doesn't really give me another log. It just comes out front. So I need to deal with it, but it doesn't really give me another log. Here I'm going to get all the way down to 1 log. So log base 6, and then I want to do 8 times 27. And kind of think about it all in parentheses like this. So 8 times 27, we are going to get 216. And then from your table, you'll know 216 to the 3rd power. So this is going to be log base 6 of 216, and that's going to be a 3. This is your answer. On 28, I'll do log base 2, and it'll be 80 divided by 10, which is going to be an 8. This is going to be a 3 right here. So I'm just going to kind of jump around some. 29, I'm going to do division. So log base 4, and then I have 384 divided by 6. And I want to go ahead and simplify that. And we'll try to keep these a little bit smaller on the actual quiz. So we have log base 4, and that's 64. And then from your table, you know that's just going to be the 3rd power. So that's going to be 3. And 31 looks kind of complicated, but it's really not. All I have to do is bring the 15 out front, And then log base 4 of 16 is really the number 2. So it's 15 times 2, which is going to be 30. That will be your answer. Okay, just moving along. So when I have parentheses, it's telling me to deal with that first. So I'm going to combine these using multiplication. So it's going to be x times y. And then I would just be dividing by z. So I'll just go ahead and write it all out like that. And there's your answer. Remember that when you're condensing, the very first thing you're going to deal with are your powers. So I'll write your order up here. So I'm going to bring the 3 up front. So it's y cubed. And then I'm just going to combine. So I have log base 9, and then I have x times y cubed. And that is your answer. 35, I'm going to do log, and then I'm going to actually multiply that and get 100. And remember that there's an understood base of 10. 10 to the second power gives us 100. So I think you're probably getting the gist of those. So I did through 35. I want to make sure I have time to do some from the next little section because they get kind of challenging. Now these are ones where you're going to rewrite and solve. So you can see it's kind of sectioned out, and every little section requires a different skill. This kind of combines a lot. So I'm going to rewrite using my conversion. So I'm going to go 3 to the negative 4 is equal to n. So 3 to the negative 4 is equal to n. So here I'm just simplifying this left side. And remember that 3 to the 4th will be on your table, and that's just 81, but it has to be in the denominator. So it'll look like that, 1 over 81. Here we have n squared is 196. And I'm pretty sure that's on your table. I'm not really using it right now, but I'm pretty sure that's on your table. You wouldn't be expected to just know that. That's not too bad, though. Y'all could remember that. That's just going to be 14, of course. So that's on your table. And 4 to the 3rd is n. So that's pretty simple. So when you rewrite it, it opens up the door for you to actually solve whatever it is you're looking for your n. So this whole thing, the n actually simplifies down to a 64. Now I do want to do 42. I've kind of been skipping around, but I want to make sure you remember how to do this. This is really the tenths position, hundredths, the thousandths, and the 10,000. So it's really 1 over 10,000. That's important because you're really replacing that with that. So I need 10 to some power, and I know it's going to be negative, and it's going to have 4 zeros. So it's going to be x is a negative 4. Okay, n to the 1/3 is 6. So n to the 1/3 is equal to 6. Now I want to show you, and I did this in class, I want to make sure you remember, if I raise both sides to the 3rd power, these are going to cancel out. I'm going to get n to the 1st, and then 6 cubed, of course, is just going to be 216 from your table. So make a little note that when you're solving for the base, you want to make sure you remember this little option. You can actually just raise to the reciprocal, and I'll do another one in just a second like that. Okay, so these are, they look kind of different, but 5 squared is going to be n minus 3. So that's going to be 25 is equal to n minus 3. You would add 3 to both sides, and n would be 28. And I think I'm going to do this one right here. 4 to the 3rd power is n plus 1 cubed, all cubed. So 4 to the 3rd is n plus 3, all cubed. And of course I can go ahead and simplify the left side because I know 4 to the 3rd is 64. But once I look at that, did I really need to do that? I really didn't, because at this point I'd probably just take the cube root of both sides anyway. So when I get to this point, if I have the same exponent, now this only works if you have that same exponent, I would basically just say 4 is equal to n plus 3. So I'd subtract 3, and n is just going to be a 1. And so 4 to the third power, if you write it like that, is going to be 4 to the third power. So just kind of check your answer there. Now I want to get to one that you actually have to factor on. So it might be one like 51. So n squared is n plus 2. And whenever I end up with this n squared, I know I have to deal with the quadratic. Probably just going to be able to factor it though. So I want to move everything to one side, set it equal to 0. So n squared, and then that would be a minus 0, and that would be a minus 2. And then I have to factor this. So I'm looking for factors of negative 2 that add to a negative 1. So that's just going to be a positive 2 and a negative 1. Sorry, I got that backwards. That will be a negative 2 and a positive 1. Always check your work. So n times n is n squared. This is n. This is minus 2n to give us this middle term. And then negative 2 times 2 is negative 2. Now, I have to set these equal to 0 to solve. But remember, this sign will just kind of change. You're really using the zero product property, though. And this will become a negative 1. Now, we need to make sure that we're not trying to take the log of a negative value. So in other words, take the 2 and plug it in, log of 4, so this one will work. Negative 1 plus 2 is still a positive 1, so this one will work as well. You cannot take the log of 0. No matter what the base is, you cannot do this. Because remember, the base cannot be 0. There's no way to raise that to a power and for it to equal 0. So you cannot take the log of 0. All right, so I'm going to pause the video. You're going to finish working them, and then I'm going to show you the answer key. Okay, I'm putting up the entire answer key so that you can check it. I'm going to kind of just scroll down. What you're going to want to do is pause the video, check your work, and then continue on. So I'll just kind of scroll slowly. Okay, so those are all the answers, and hopefully you can, hopefully you're understanding everything, and go back, and I'm also going to send out the answer keys for day 12 and day 13, and this is just the extra practice from day 13. And y'all have a great day.